Okay, so today we are going to start back on the front and we're going to use limit properties to simplify functions. All right, so we have 7 properties of limits to go through. I'd say all of them except for the 7th one are like almost self-explanatory. Maybe not the first one, but once I show you 3, you're gonna be able to fill in 4, 5, and 6. But if we have the limit as x approaches some number of just a number, what do you think that limit would be? Somebody knocking? Okay. It's just going to be the number. There's nowhere to do the direct substitution. There's nowhere to plug in the value, so it's just going to be whatever the number is. So in these properties, A is always representing a number, and C is also representing a number. All right, and then on number 2, if we have the limit of the product of a number and a function, we can take that number value and just multiply it in front of the limit. Okay. Great. And then the third property, if we have the limit of the sum of 2 functions, we can rewrite it as the sum of the limits. So it would be the limit as x approaches a of f of x plus the limit as x approaches a of g of x. And then that same idea holds for subtraction, multiplication, and division of 2 functions. You can rewrite them as they each get their own limit. All right, and then the composition one is really the only one that is just kind of different. So like on all these other ones, like we had f and g, f would get a limit and g would get a limit. It doesn't happen on the composition. So if we have the limit of f of g of x as x approaches a, we can rewrite that as f of the limit as x approaches a of g of x. So you do a limit for g, and then whatever you get, you just plug that into f. So that's just a little bit different. And that honestly doesn't come up enough for you to get really good at it. But we'll practice it as much as we can. You just don't see problems like that too often. All right, so let's flip over and go to G. Before we do that, or you can go ahead and flip, we're going to use these memorized forms quite a bit today, particularly these 2. So if we have these limits, we're just going to get 1. If your x has a coefficient, you just need to make sure that denominator has that same coefficient, and it's still going to be 1. Okay. All right. So we are going to rewrite this fraction as something that is equal to it, but written in a way that we can find the value of the limit. I'm not necessarily using the properties yet. So when I look at that, and I see this sine of x over x, I know that's special because we just looked at it. So I would write this as the sine of x over x, and I would multiply that by another fraction. that's going to be equal, like, so when I multiply them, I do get this exact same thing. So what would I multiply sine of x over x by to get this? Very good, thank you. I had to say that with so many words, I don't know why. All right, so now this is the limit of a product. We can rewrite it as the product of limits. So now, what is this first limit going to be equal to? Just 1. All right, and then I can do direct substitution with this other limit. I can take that 0 and plug it in. I couldn't do that for sine of x over x because you could, but you get 0 over 0. That's why you need to have that memorized property. All right, so this is going to be 1 over 2 times 0 minus 1. So we end up with 1 times negative 1, or eventually just negative 1. All right, any questions? Okay, let's look at h. All right, so h is almost ready for us to find the value of the limit. What do you think is wrong with h right now? Yeah, we have this 3 here. I don't have it here. We cannot get rid of this one. Like, it's like when you have the sign of something, some angle, we can't really change that. But I can make sure this denominator has that 3 by multiplying by 3. Plus 2, plus. Is it legal to just do that?
No.
What else do I have to do? Multiply the numerator by that. That is like multiplying by 1, and that's perfectly legal. So I'm just going to rewrite this for a second. All right, now I'm just using all these properties, writing it all out. If it is a multiple choice question, you don't have to write all these steps. For a free response, it would probably be a good idea. You likely would get credit just for writing out the steps, or get points just for writing out the steps. So I am going to use that second property where I have a number multiplied by a function, and I'm going to take this 3. I'm just going to move it in the front. Then I know that the limit of sine of 3x over 3x as x approaches 0 is just 1. And so my final answer should be 3. All right, Milo, I'm not sure if you were in here. On I, we're changing the 0 to infinity. Okay, so we're going to kind of do something similar to what we did here. So we rewrote this fraction as 2 fractions multiplied by each other. We're actually going to rewrite this fraction as 2 fractions added to each other. All right, so we're still going to have that limit as x approaches infinity. But we're going to rewrite 3 plus 7x over x as 2 fractions added. What do you think their denominator needs to be? The common denominator of x. All right, so you guys see if you can figure out what those numerators should be. So when I add these 2 fractions, I get that original one. All right. So you can break apart fractions if typically you do it if the denominator is a single term and there's addition or subtraction there. You can break it apart. Put each one of those over that denominator. Okay, so now I'm going to write this as the sum of two limits. And I am going to simplify 7x over x. Then I'm going to do direct substitution. This might be the first time we're doing direct substitution with infinity, unless you did it on your assignment last night. But I would put the infinity in the denominator. There's nowhere to put the infinity with 7, and we already knew that that's the very first property. That if you have the limit of just a constant, the answer is just that constant. So what is 3 divided by infinity? 0. So this ends up being just 7. All right. What questions do you guys have so far? Too bad? All right. So the back is really focusing on the properties. And these are pretty typical questions you'll see on the AP test to make sure you really do know these properties. And so we know that the limit of h of x as x approaches 2 is 5, and the limit of g of x as x approaches 2 is 0. So we're going to use that to find the other limits. And so most likely you would see this on the free response question part, I would think. And if you do, you would get a point for writing out the property. So with the AP exam, you kind of, instead of thinking of it as losing points, you think of it as gaining points. And so just for writing that, showing them that you know that property will most likely get you a point. And then the second point would come from getting the right answer. I definitely didn't give you guys enough room. I don't know why I didn't spread it out here on the back, but that's okay. All right, so I know from the directions in the problem that is going to be 0, and that is going to be 5. So when I add them, I just get 5. Now, if it was a multiple choice question, I probably wouldn't write that out. I would know in my head that you just add those two numbers together, and that's fine. But definitely write it out. Your work matters on free response. All right, so let's do them in order. So B, what would you guys do with that 3? Yeah, let's just jump it out in the front. And again, you would most likely earn a point for writing out the property. And then the second point is going to come from the answer. All right, so why don't you guys try C and D on your own, please? What do you guys think about the limit on D? Does the limit exist? Does not exist. I know it gets confusing. Whenever you're talking about points on the graph, that's when you say the graph is undefined. When you're talking about limits, you said the limit does not exist. Just think, Mean Girls. You'll be fine. All right. And then on example 3. So this is an example using the composition, of the limit of a composition. So when we rewrite this, the G doesn't have a limit, just the F. All right, so G is going to hang out. I am just going to do direct substitution. So both of these, the limit is going to exist everywhere. You would never get anything in the denominator. So I would just take 1 and I would plug it in to f of x. By direct substitution. And now it's just regular function notation, find G of 4, which means just plug that in and cube it. So the final answer is 64. That's not the best example for this situation because that just feels like doing a regular composition. So I'll try and see if I can find some, like maybe with a graph to help you understand. Like in this case, you do the limit. In this case, you just find the value.
What is a piecewise doing here?
Oh, piecewise and limits, they go hand in hand. They go hand in hand just perfectly. You'll do lots of limits with piecewise, and it's not too bad. Before this year, I'm pretty sure, you would only, like if you were evaluating, you would only plug 1 into one of these functions. Which one would you plug 1 into? Yeah, the top one, because it has or equal to. This is different. We're not finding the value. We're finding the limit. And so if we are finding the limit as x approaches 1 from the left, which one of those is when x is approaching 1 from the left? The top one. The left side is the top one. So we plug 1 in there, direct substitution. All right, for B, we're finding the limit of f of x as x approaches 1 from the right. So we are going to plug it in to the second one. Not because we're evaluating the function, but because we're evaluating the limit. And this is going to be the part of the graph that's on the right side. So it looks like we're going to get negative 2/5. So what do you guys think about the limit of f of x as x approaches 1 from both sides? Does not exist. Good. Why does it not exist? Right. All right, so I have double checked the assignment. It is correct. This is exactly what I want you to do. I'll jot it down, or you can copy it from the board, either one. And I can put some books out, but I have already taken a picture and put it on Google Classroom. If you want to actually use the book, you can. So in 58 and 57, I don't want you to do